Hey everyone, I just wanted to do a quick introduction to net present value for those of you who aren't necessarily already comfortable with the topic, so that when we go over it on Friday, you can come up with some good questions and make sure that by the end of the day you understand the topic and feel comfortable with it. It's a hard, complex, deep topic in some sense, and it'll take some effort to get it. Okay. Uh, the thing which I believe is important for understanding net present value is understanding the assumptions that are used to make it make sense. So when you read this chapter and you're trying to understand net present value or yield to maturity, it's very helpful to stick with a couple assumptions. First, uh, and these assumptions are kind of an idealized world. We're going to understand net present value in this idealized world, and then uh, the understanding will carry over to some degree to the real world. So we start with this idealized world, and then we see if it applies. Um, in this idealized world, everybody's going to repay all debts. It's a simple assumption, obviously not true about the real world. We'll see if it carries over. I think it carries over pretty well in terms of the intuition you can gain about net present value. Also, for simplicity, we're going to assume that there's only one interest rate. We're going to call it I. And that means that you can save as much as you want and earn I% interest on your savings. Everybody can do this. Everyone can save as much as they want and earn I% interest on it. Everyone can go to the bank and put as much money as they want in the bank and earn 9% interest. Likewise, everyone has amazing credit. Everyone can go to the bank and borrow as much as they want and only pay I% interest. So these are the assumptions that we're going to make. They'll be in the background the whole time. So with those assumptions in the background, we're going to now look at three questions. The first question is, if I put $100 in the bank now, how much is that $100 going to be worth in N years? And I'm going to assume you have some background on this. I'll go through it pretty quickly. The next one is kind of a corollary of the previous one. It's how much would I have to put in the bank today to have $100 in N years? We're going to use that to introduce the concept of present value or present discounted value. And then finally, we're going to ask the question of how much would I have to put in the bank today to receive cash flow 1 year from now, cash flow 2 years from now, cash flow 3 years from now, etc. And we'll use that to introduce the concept of net present value. So let's try to answer that first question. I'm going to switch over here to OneNote. And I just want to say, suppose you put $100 in the bank right now. It's worth $100 right now at t equals 0. At t equals 1, you are going to have $100 times 1 plus I, because that is the interest rate. At t equals 2, you're going to have $100 times 1 plus I squared. If you don't understand this calculation, this should be a review. If it's not a review, if this is new to you, you definitely want to ask me. It is important. I will assume you have this. Next, at t equals 3, you're going to have 100 times 1 plus I to the, skipped a step, to the third power. And then, as you might guess, after n periods, after n years, you will have 100 times 1 plus I to the n. Okay, so that's pretty simple. The next question, and what we get is an overall formula that if you take a certain amount of cash, some sort of deposit, and you want to find out how much you will have in the future. We will call this the future value of the deposit. You just take the deposit and then multiply it times 1 plus I to the n, and that tells you the future value. Well, there's an interesting corollary to this, and this is where we get to the second question. If you want to figure out how much of a deposit you have to make today, in order to have a certain future value later on, such as $100, you can just use this equation to solve for it. You just divide both sides by this term, and you get the deposit that you have to make equals the future value over 1 plus I to the n. In this case, if we want to have $100 in the future, because that is that second question, it's right here. If we want to get that $100 in n years, the amount that we have to deposit is $100 divided by 1 plus I to the n. Okay, fair enough. We've answered our second question. And we have two equations. The first equation is if I want to figure out the future value of a certain deposit, I just take that deposit times 1 plus I to the n. If I want to figure out how much I have to put in the bank in the present, what sort of a deposit I have to make in the present, so we could call this the present value of the investment because I'm depositing it today at that value, I can do that as, in the second formula, FV divided by 1 plus I to the n. So now we have our two formulas. Okay. Let me grab that formula that the present value equals the future value that we want over 1 plus I to the n. Now, if we want some sort of cash flow to come to us in the future, like n years from now, we want CFN. CFN just stands for a certain amount of cash that we want to receive in the future. We just write that as the present value that we have to deposit now equals CFN divided by 1 plus I to the n. I guess before we go on, there is one more thing that I want to talk about and mention briefly. And it comes back to those three assumptions, or those four assumptions that we were making. So if everybody is repaying all debts and everybody can borrow and save as much as you want at I% interest, then to some degree you are really, I suppose I'll zoom down here a little bit, you are really indifferent between receiving $100 today and receiving $100, and I shouldn't do this as an equals. I'm going to say a kind of a curvy equals to indicate indifference. $100 times 1 plus I to the n in n years. In some sense, in a deep sense, these are exactly the same to us. Suppose I is 10%. I'm completely indifferent between receiving $100 today or $110 a year from now. Because if I'd rather have the money today and instead I'm getting it next year, I just borrow $100 today and pay that money and then use the future cash flow to repay my debt. So for example, I have $100 today and I wished I had $110 in 1 year. In that case, what I do is I just take this $100 and I put it in the bank, and miraculously, almost as if there were a time machine, that is transformed into $110 in 1 year. So to me, I'm completely indifferent between having the two. Likewise, if I knew that I was going to receive $110 in 1 year, but I didn't want it then, I wanted $100 right now, I could go to the bank and I could take out a loan of $100. I could borrow $100. Of course, I have to pay back $110 in 1 year, but exactly 1 year from now, I'm going to be receiving $110. So I'll just use that to pay it back. And now, essentially, I have the $100 today. So I really am completely indifferent between $100 today and $110 in 1 year. Likewise, if I take 100 times 1 plus 0.10, 10% interest rate squared, that equals $121. I'm completely indifferent between $100 today, $110 in 1 year, and $121 in 2 years. Going back to this formula, in general, I am indifferent between $100 today and 100 times 1 plus I dollars in n years. More in general, using the same logic that we used down here, I am indifferent between receiving the present value of a cash flow today and receiving the cash flow n years in the future. That is exactly the same thing. So I could either receive this cash flow today, I could either receive the cash flow n years in the future, or I could receive the present value of the cash flow today. Same exact thing for me. Don't really care. This is important because one of the absolute key things that we will be focusing on in this course, or that one always thinks about in finance, is valuation. How much is that future cash flow worth to me today? I mean, this is a cash flow in the future. I know that in general, people want money now. I'd rather have $100 today than in 10 years. Pretty much everybody would rather have money now than in the future. But how much is a future cash flow worth? This is saying that if we buy these crazy assumptions, I'm trying to convince you that the value of that future cash flow is exactly given by this formula. It's pretty cool. Because if I had this and I wanted this, I just go to the bank and I borrow this money, and I have to pay it back in n years, but that's exactly when I'm getting this cash flow. So I can transform this into this. And likewise, I can transform this into this. Suppose I have this and I want this. I just go to the bank and I deposit this amount of money. Today, I deposit CFN over 1 plus I to the n. And then after n years, I will have 1 plus I to the n times as much money. That cancels with that. And then in n years, I have exactly this, which is what I want. So really, these two things are exactly the same. So if you want to evaluate this, you just calculate this and you know how much it's worth. Okay, I beat up that topic, banged it in. I hope you will ask me questions. Finally, I have that third question that I wanted to cover. So let me do it. Let's bring that formula one more time, that the present value of a future cash flow in n years is just that cash flow, the amount of that cash flow in dollars divided by 1 plus I to the n. That's nice if you're just receiving a simple cash flow of n dollars at a specific time, but that's not the way that the world works. Usually, you get more complex cash flows. You will get a certain cash flow today, plus a certain cash flow 1 year from now, a certain cash flow 2 years from now, a certain cash flow 3 years from now, and so on. So how do you calculate the present value of all of those? How do you figure out the value of all of those? Remember, present value is used to calculate the value today. That's what the name means. It's the present value of those future cash flows, meaning how valuable is it to you? Well, You know that you could put a certain amount of money in the bank and get CF1 in the future, 1 year in the future. How much do you have to put in the bank? You just take the present value. So today, in order to replicate, in order to get this cash flow 1 year from now, I'd have to put this much in the bank. Okay, if I wanted to get this much 2 years from now, it's the same idea. I just take the present value of that. If I want to get this, I just take the present value of that. If I want to get all three, well, that means I'm going to have to basically have 3 bank accounts. I put this much in one bank account, this much in another bank account, and this much in another bank account. At the end of 1 year, I take this money out. At the end of 2 years, I take this money out. And at the end of 3 years, I take this money out. Okay, OneNote is kind of weird. I'm getting used to this. All right. In order to replicate, to get all 3 of those cash flows together, I just need this much money total. This much for the first cash flow, this much for the second cash flow, and this much for the third cash flow. We call this the net present value of these 3 different cash flows because we're adding them up. Well, okay, and it could go on, you could have cash flows all the way for a very far distance in the future. You could also have a certain price that you have to pay today. You don't have to discount that back to the present because that is a current price. So if you want, you could also in the calculation put the price. But generally, when we're talking about the present value of a future series of cash flows, we will just talk about the future cash flows and take the present value of each of those cash flows and then add them up. So overall, when you hear the phrase net present value, what you do is you take each of the cash flows, you discount each of them to the present, and then you add them up. And that is how you calculate net present values of future cash flows. You use those for calculating prices, for valuing those future cash flows and deciding how much you're going to pay for them. What does that have to do with the course? Well, the future cash flows, if you remember the definition of a financial instrument is just a promise to pay a certain amount at a certain time under certain conditions. Well, those are your future cash flows. You can see how that connects in. We can use this tool of present value to calculate the present value of any financial instrument. As long as we know what the future cash flows will be. So if we believe that we'll actually get paid back in a debt instrument, we can use this to calculate the values. Later on, we'll talk a little bit about what do we do when we want to add risk into the model.